Hello, my name is Nur Suzana binti Abu Bakar. Today we are going to present about chromatography in forensic science. First of all, definition of forensic science is the chromatography forensic definition includes the law aspect of science, stating that chromatography is an analytical procedure used to physically separate mixture with the goal of identifying substance from criminal evidence during the process of forensic analysis. The purpose of chromatography in forensic science is used to identify and compare drugs explosives in and biological samples such as saliva, urine, blood, and other. Then we are going to talk about types of chromatography in forensic science that we use is gas chromatography (GC), high performance liquid chromatography (HPLC), thin layer chromatography (TLC), paper chromatography (PC), and liquid chromatography (LC).
IUPAC defines chromatography as a physical method of separation in which the components to be separated are distributed between two phases, one of which is stationary phase, while the other, the mobile phase, move in a definite direction. The possible mobile and stationary phases can differ greatly depending on the type of chromatography being performed and the nature of the sample being analyzed. Chromatography in forensic science encompasses a diverse array of techniques designed to separate, identify, and quantify substances of interest within forensic samples. At its core, chromatography relies on the differential interaction between analytes and a stationary phase within a chromatographic system. As the sample components traverse through the system, they undergo partitioning between the stationary and mobile phases, leading to their spatial separation based on specific physicochemical properties such as polarity, size, and affinity.
Next, for methodology, we have types of chromatography, steps in chromatographic analysis, and importance in forensic science. Basically, chromatography is a vital tool in forensic science, providing reliable and scientifically valid evidence to ensure justice in legal proceeding. Firstly, we go for types of chromatography. First, we have gas chromatography or GC. This applies for analyzing volatile substance, and method that we use is the sample is injected into the chromatograph after being vaporized. Then, the sample is moved through a column by the carrier gas, which is often an inert gas like helium. After that, compounds separate according to how volatile they are and how they interact with the stationary phase of the column. Lastly, the compounds are identified by a detector such as a mass spectrometer or flame ionization detector. Second, we have liquid chromatography or LC. This applies for analyzing non-volatile and thermally unstable substance. A method that we use is the sample is dissolved in a liquid, the mobile phase, and then run through a solid particle fill column, the stationary phase. Second, the way that compound interact with the stationary phase determine how they separate. Lastly, the compound are identified using a detector such as a mass spectrometer, UV or fluorescence. Thirdly, we have thin layer chromatography or TLC. This applies for quick preliminary screening of substance, and method that we use is first, spot the sample onto a plate that has been lightly covered in an adsorbed silica gel, for example. Then, a solvent is applied to the plate and uses capillary action to transport the solvent up the plate. Then, after that, the solubility of the compounds in the solvent and their affinity for the adsorbent cause them to separate. Lastly, chemical reagent or UV light are used to visualize spot. Next, we have high performance liquid chromatography or HPLC. This applied for high resolution separation of complex mixture. A method that we use is a high pressure liquid system is injected with the sample. Second is the sample is transported by the mobile phase via a densely packed columns. After that, the way compound interact with the column material determines how they separate. And lastly, a highly sensitive detector recognizes the substance. Lastly, for types of chromatography, we have capillary electrophoresis or CE. This applies for separation of ionic species by their charge and size. The method that we use is a capillary tube that has been filled with a buffer is injected with the sample. After that, the application of an electric field causes the ions to migrate at various rates. And lastly, the separate components are identified by a detector. Next, let's move on to steps in chromatographic analysis. The process of preparing a sample for analysis involves several steps. First is collecting and preserving forensic sample properly. Second is extracting, purifying, and concentrating analytes. Third is injecting the sample into a chromatographic system. Next, detecting and identifying using the right detectors and comparing the result with standard. Last but not least, data analysis, deciphering chromatograms and identifying substance. Now for importance in forensic science, we have precision, which chromatography offer accurate material identifications and separation in complicated combinations. Second, have a versatility which suitable for a variety of forensic samples, including biological fluids, poisons, explosives, and narcotics. Thirdly, we have a sensitivity, very sensitive, enabling the detection of minutes quantities. Last but not least, we have speed, which quick analysis using contemporary chromatographic methods. Now, let's move on for example of result. We have several examples. Firstly, we have drug analysis with GC to MS. This case is a suspected drug overdose, and the result is a chromatograms display several peaks that represent various chemical components in the samples. Next, a mass spectrum is compared to a reference library to identify each peak. Heroin, 4.5 minutes, morphine, 5.8 minutes, and codeine, 6.3 minutes, are among the chemicals that have been identified. The presence of heroin and its metabolites attest to the death being caused by a drug overdose. Next, third example that we got is toxicology with HPLC. Case is suspicious death with potential poisoning, and result that we've got is chromatogram display peaks that present different substance. Cyanide retention time is 4.2 minutes, and thiocyanate retention time is 5.0 minutes, are among the identified chemicals. The presence of cyanide attests to the poisonings role in the death. Last example that we've got is environmental heuristic with LC. Case is illegal dumping of industrial waste. A result that we've got is a chromatogram display peaks that represent different types of contaminated. Compounds that have been identified include heavy metals and polychlorinated bihydrin PCBs. The illicit dumping of industrial waste is indicated by the presence of PCBs and heavy metals. Next, for interpretation of results, chromatogram is a graphical representation of separation process, identifying compound by peak, area or height, and retention times. Peak area or height indicates compound concentrations, with higher peaks indicating higher concentrations. Mass spectrum provides detailed information about a compound's molecular structure, crucial for identifications.
In conclusion, chromatography is an essential forensic science instrument that has revolutionized the field of forensic inquiry. Chromatography is the best method available for determining the identities, concentration, and size of the chemicals present in forensic samples. Applications include arson investigation, toxicology, drug analysis, and trace evidence analysis. By exploiting chromatography's analytical power, forensic scientists and investigators may solve complex criminal cases, provide compelling evidence in court, and ensure that justice is served.